Welcome to Knowledge Base. We have a really interesting question here. The question says that a wire of resistance 8 ohms is stretched uniformly to twice its original length. What is its new length, or rather its new resistance? We are told that the resistance of the wire is 8 ohms and the wire was stretched. First, let's look at the formula for the resistance of a wire with respect to its geometry, that is, its length and area. We know that the resistance of a wire is equal to rho L over A, where rho is the resistivity of the wire, L is the length of the wire, and A is the cross-sectional area of the wire. So for this given resistance of 8 ohms, it has a given length and a given cross-sectional area for a constant resistivity rho. However, the length was increased or it was doubled. So it means the new length, let's call it L prime. The new length is now twice its original length, L. So L prime equals to 2L. You will agree with me that the wire has a constant volume because it is the same wire that was stretched. And so when the wire was stretched, it means that the cross-sectional area will become smaller because once the wire is stretched, it will become thinner. So if we double the length, what now happens to the area? That means we're also going to have a new cross-sectional area. How do we get that new cross-sectional area? We know that the volume of that wire is constant because it is the same wire that was stretched. And volume V is equal to area times length. What it means is that area, if we make area solve the formula, it implies that the area is equal to volume over length. So for this wire, its area is equal to the volume, that constant volume, divided by its length. Now, what will be the new area? The new area will become that same volume divided by the new length, and the new length is 2L. That is 2L. So A prime, being the new area, is volume over 2L. Remember, volume over L is area. What it means is that the area, the new area, will be half of the original area. So the new cross-sectional area of the wire, when the length was doubled, is now half of the original area, which makes sense because when you stretch the wire, it becomes thinner. So while the new area is now longer, double the original area, sorry, while the new length is now longer, double the original length, the area is now half of the original cross-sectional area, which makes a lot of sense. Now we know the new length, we know the new area, we can now calculate the new resistance. So bringing this formula back, the new resistance R prime will be equal to resistivity times the new length divided by the new area. Remember, there is no new resistivity because the resistivity of a wire is constant. It is the property of a given wire. Now, let's plug in the necessary values. So the new resistivity R prime will be equals to rho. The new resistance R prime will be equals to rho. The resistivity, the new length is now 2L divided by the new area is now half of the original area. Remember, when you are dividing a number by a fraction, the denominator of the fraction multiplies that number. So what it means is that these two will come up so that the new resistance will be equal to resistivity 2 times 2 gives us 4 L over A. Let's rearrange this so that the new resistance will be equal to 4 times rho L over A. I just use this 4 to multiply the whole thing. It's the same thing basically. Now take a look at something. Rho L over A is given as the resistance, the original resistance. What it means is that the new resistance is 4 times the original resistance, which gives us 4 times 8. And the final answer for the new resistance is 32 ohms. So by stretching the length of the wire to double its original length, the cross-sectional area is halved, and that makes the resistivity to increase 4 times. It quadruples. The resistance quadruples when the length is doubled, resulting to half its cross-sectional area. So this is the answer to the question. 32 ohms is now the new resistance, and it is very simple and straightforward. If you understood this, I have a simple one for you on the next page. Read the question carefully, calculate the total resistance of the circuit, and put your answer in the comment section. I will be there waiting for you. If you find this video useful and insightful, please like it, drop a comment, and share it to others. Most importantly, follow our page. The link to our YouTube channel is in the comment section of this video. Do well to subscribe to our YouTube channel because there are more exciting contents happening there. Thank you for watching and hope to see you in our next video.